Yeah, I like that. Yeah. Let's see.
All right, so what we got? Kelly?
So 7.3, for the distributive properties, I get most of it. I just want to be sure if you could do a couple examples of
Sure.
just these ones here, however you want to do that. But
Oh,
I'm not sure because I get it right here, so the middle part to jump and do that. But then I'm confused almost.
Gotcha. All right. By the way, anybody need, if there's chapters, sections, and stuff you've missed, I'm just going to put them up here. Chapter 7, part 1 and 2, chapter 8, chapter 6, 7. Okay. All right, so the question on the table is from 7.3, some of those later ones. We did an example from the homework last time. Let's do another one here. Here's one that trips people out. 133, for example. Whoa, that was powerful. Nice and high.
There's other stuff for that.
So we talked about one like this last time, but what's in front of this? There's always an understood one.
Okay.
So just see how this one, you see why they did the parentheses here, so they see there's one thing minus another thing, right? But are these parentheses mathematically necessary? No, because there's just a one. What's one times anything? It freaking self. But what's in front of this other dude? Negative one. So when you bring that through, the y becomes negative y. Negative times negative 2 is plus 2, and now just put your like terms together. So the thing to realize there is that negative sign itself can be distributed because it really is a negative 1 sitting there that has to be distributed. Yes, sir? Yeah, 3y. Plus 1. Cool. I don't know, real quick, I don't know if I ever showed you this. If you have time and if this makes sense, what value of y does this work for? Every value of y. Because we just did this. What is this? And this is a more fundamental idea. What does this really mean? It means that this thing is this thing. No matter what y is. So go with me for a second. Now, everything I'm about to do in purple is nothing to do with what you got to do for homework. But it's still good to see in action. So what could y be? Let's say, what if y is 4? Stay with me for a second. It's kind of neat. This is the part you guys don't get to see. Algebra is so difficult because you're actually working with an infinite number of numbers at once. How many things could y be? An infinite number of things. Holy shit. So it's kind of nice sometimes, if you realize what's happening, to give yourself something more concrete. If y is 4, what is this number? 4 times 4?
16.
Minus 1? 15. Minus, and what is this number if y is 4? 4 minus 2? 2. So that should be 13, right? Right? Yeah. Let me like that. Is everybody cool with that? Where did 4 come from? From here. I could have made it 5. I could have made it 11.893. I could have made anything. Why? Because y could be anything. So just to give myself one concrete example, right? Which is what algebra students always, please give me something concrete. None of this X shit. Well, you can give yourself something concrete, because what could X or Y or anything be? Anything. So that's 13. This is 13 if Y is 4. So this better be 13. Because they're supposed to be the same damn thing, right? When sure enough, what's 3 times 4? Plus 1? Frickin' 13. So that's actually a way to check your work. You can plug a 5 in, plug a 6, plug a 2, whatever, And it better come out the same as this, because that's what that means when you do this algebra, is that is equivalent to that. That's what it means. Do you have to ever do this in your whole life? No, you don't have to. But even if you don't, I hope it makes sense. Okay. I felt like I was in a sitcom or something. Yeah.
I have a question on 7.3. Which one?
Where did I put my little? Oh, there it is. 7.3, 29? 129. Oh, it's the same thing as the one we just did.
Yeah, you put a question on my
I did, because you had some weird 2 reasons. 8 times 7 is 56, not 63, but also, there's nothing being multiplied by 8. In number 129, there's no multiplication by 8 being done. What is 8? Something is being what from 8? Yeah, subtracted from 8. So you're not going to distribute 8. What operation should there be here if you're going to distribute 8? What should this look like if it meant to distribute the 8?
It would be negative 8.
Yeah, sure. It could be negative 8 times r minus 7. And then I'm distributing negative 8. Sure. That's not what that says. This says 8 minus. So guess what? I'm going to do the same thing to that piece that we did to that piece. Because it's the same idea. It's 8 minus r plus 7. Because a negative in front of something does what to it? It changes its sign. So what's the negative in front of both of these? So both of those signs change. You guys see that? A negative in front of something will change its sign. You guys agree with me? Not from Sagittarius to Cancer, but from negative to positive and vice versa. Right? So a negative in front of negative 7, what does that become? Yeah, so a negative in front of something changes its sign. So a negative in front of 2 things changes both of their signs.
That answer would be
Yes.
1 plus r, right?
No. What's 8 plus 7?
15.
There you go. Yeah.
So if there was an 8 in front of the negative on that.
Yeah, like I just had written down. So the problem would have been this instead. Then it would have been negative 8r plus 56.
I was talking about like the 8 in front of the negative.
It is in front of the negative.
No, that.
Oh.
So it would be 8.
Now watch. What's negative 7? Let me do something we never do. I'm going to write the plus sign. Is like, well, why don't we write it? Because if it's not there, we know it's there. Same thing, reason we don't write the 1. Just to save a little bit of time. Now watch. So Alan's asked me, well, there's an 8 here. Well, then it would have been 8 plus 7. See, the 8 just comes for the ride, right? So what do you do with that? You bring the negative through. Oh, there's an 8 there. Okay, there's an 8 there. So then you just put your like terms together. Yeah.
For that one, the first problem that you did, you got 1 right. Don't you add 1 to both sides on that one?
Where are there both sides? I don't see 2 sides.
Negative 1, is that a 3 or a 2 for the when you have it?
The 2 there? Well, it's a curvy underline, so yeah, it's a 2.
It's a 2. So shouldn't there be 3?
No, I don't see 2 sides up here. What defines sides? What you're talking about is if you add 1 to one side, you add 1 to the other side, that kind of thing.
Yeah.
I don't see 2 sides up here. What defines sides? An
equal sign.
An equal sign defines sides. There's only 1 side here, right? Do you guys understand that? So, let's see. So you're thinking I have to add 1 here and add 1 there or something?
Yeah.
But you see how that doesn't make any sense. This is a good question, Daniel. I'm not coming down on you, but this is actually something that I see a lot of. All right, what is 8 plus 1? 9. Does it change? So if I have $8 and I find $1, I have $9, right? But what if I have $8 and I owe somebody $7 and then I find $1? This should still be 9 freaking bucks minus the 7. I shouldn't have to go plus 7 plus. I mean, do you see what I'm saying? It's all on one side. There's no sides to change to. But if this was x plus 1 equals 7, I've got two sides. In order to make sure the equality is still true, if I subtract 1 from one side, I've got to subtract 1 from the other side. And the reason that is give me something 6 equals 6. That's amazing stuff, right? 6 equals 6. If I subtract 1 from that, how do I make it still true? Yeah, if I don't do this, it's not going to be true anymore. So whatever I do to one side of an equation, I must do to the other side also. There's no other side here. This is all one side. There's no two sides.
So you only do that when they're like an equal sign?
Yeah. And another big thing is, really, watch this. Isn't this, all right, I want you guys to understand. Isn't this plus and negative? Is that cool, right, like that? Minus is plus and negative. Minus, and that's it. That's, I think, and then minus is plus and negative. Is that cool? Let me try this again. All right. So I got 4y minus 1 minus y plus 2, right? All right. Now, going back to something we talked about earlier this semester. Subtracting is adding a negative. Same thing. Subtracting is adding a negative. Now, so what I'm really doing when I'm underlining these like terms and then putting them together, I am actually using, commutivity. Because I could, and I try to make it so that you don't write that much. But I could actually write this, and I actually am doing this. 4y, I'm going to commute these two. I'm going to put the plus negative y here, and I'm going to put the plus negative 1 there. I'm just commuting them. I don't need to move them from one side to the other. I don't need to make them disappear from one side and show up on the other like I do when I solve equations. I just need to put them together. They're out of order. Just change the order. That's all I'm doing. Right? So they don't have to become a different sign to do that. They stay what they are and then they just move. Right? So now this is still going to be 3y and this is still going to be 1.
So putting like terms together?
Yes. So you don't actually have to do this. If it helps, you can. But you're definitely not going to add 1. Because what did you actually just add to this whole thing? You added 2. Is the number the same anymore if you add 2 to it? Will a number stay the same if you add 2 to it? No. Of course not, right? You guys are looking at me like I'm saying. But his question is a good one because I see that all the time. When you first learn how to solve equations, you start doing that add the number to both sides thing when there's not even two sides. Doesn't make any sense. When there's just an expression, you're just putting like terms together. If you need to move something from one side to the other, that's a little bit freaky. You've got to do it in a certain way. You've got to make it disappear on one side and show up on the other side. Yeah. What do I mean by that? You guys, exactly what you would do here. Do you remind me what would you do here? Yeah, you're making the one disappear there, aren't you? Why'd you subtract 1 so it would disappear? So it shows up on the other side. So then you get x equals 6. Right? Okay. Maybe. So yeah, if there's no equal sign, if you only want to boil that down to just trigger, when do I do this, when do I not do this? If there's no equal sign, you're never going to do minus, ever. There's no two sides. Doesn't work. Okay, I like it. Anything else from homework stuff or?
Example is one.
Which one?
Example. Can you see?
Can I see what? Sorry.
Example.
Well, what are we looking at? Okay.
Page 679. 679.
Which example? What about 24,575? That one?
Is wrong. The solution, the last is wrong.
Yes, you're right. Yes. They didn't add the 875. Good. Okay. Sure.
I've got one more question.
Are there typos in books? Yes. What's really nice about there being a typo in this book, there's always going to be typos in every book. How much did that typo cost you? Nothing. If you paid for this book, I feel bad for you. Somebody took advantage of you. Don't let that happen. Do you understand what I'm saying? Yes, that's a typo. You're right. So example, didn't even have an example number. Example 8.12 starts at the bottom, page 678, chapter 8. They just never added the 875 there in the last step. Yeah. Thank you. Yeah. Oh, go ahead.
Oh, I have a homework question.
Sure.
108 on 7.3.
Oh. So let me build up to it. So guys, what's 4 times 5? 20. If I put the 4 on the other side, it's the same thing, right? Okay. So what's 3 times x plus 1?
3x.
Plus 3.
3.
All right, so what's x plus 1 times 3?
Same.
Yeah. So just because they put something at the end, you normally don't see that because we normally put this as a coefficient. But technically, this means the same thing. It just distribute from that side.
Yeah, so would it be py? Like if it has
Totally.
water?
Yeah, yeah. Yep, totally. What's p times y? Py. Right, because I don't know what the hell that is. P times y, is it green? No, it's py, because I have no idea. Depends on what p and y are, and I don't know what they are.
So would it be py plus p4? Or
Yeah.
would it be 5?
Well, we know that we don't put P4, we put 4P, right? We always put the coefficient in front. Technically, if you put P4, I can't complain too much, but I will say, well, we don't write it like this, you know. There's a problem, actually, there's a problem like this that I would think somebody would have a question about. It says, use commutivity to rewrite this.
That's what
And I felt that coming.
Yeah,
I felt the
I
disturbance.
just skipped the whole section. Do it.
So use commutivity. Hopefully something like this. If I said use commutivity to rewrite this, what would that look like? Use commutivity.
What's
Commutative
commutative?
property. Oh shit. Commutivity is when what moves? The number, the individual things. So how would you use commutivity to rewrite this? What's that? That's amazing. Nothing major. Now this is a little bit weird, but still, use commutivity. What's the operation multiplication? So this is currently negative 2 times a. Switch that. What does it become? Oh, yeah, I would accept that. But a times negative 2. It really doesn't matter if you leave the negative out front. That's cool. So you could say a times negative 2 or negative a times 2. Doesn't matter. Now, I like that you guys don't like this because this is not the way we normally write it. But mathematically, that's the same damn thing. What's negative 2 times 5? Is it different than 5 times negative 2? Hell no. So negative 2 times a is the same thing as a times negative 2. They're the same thing. It's just that we don't normally write it. It's not convention to write it like that. But that is an equivalent statement. Okay. Maybe. Who did I left somebody out. Kelly, did we get your...
Yeah, that's where I was going with it. I was trying to figure out last night what the commutative. So I was gone that day, so.
But you could read about it.
Yeah.
Okay. Yeah.
On 7.5, 294.
There are just 75. Oh yeah, so that's the one about the temperature, right? So we did talk about metric, we did talk about temperature, we just haven't talked about general unit conversion. We're going to talk about that today. The two temperature formulas we got with this one, right? And then if you subtract 32 and multiply by 5/9, you get the other one. So there's just two temperature conversion formulas that are just known. That's how you go from Fahrenheit to Celsius or from Celsius to Fahrenheit. So in problem 294, they say 22 degrees Celsius equals how many degrees Fahrenheit? Which formula would you use? You technically could use either one, but which one's smarter to use? What do I not know? I don't know F. So I'd like an equation where it's solved for f already. So which equation am I going to use? The top one. Because if I throw 22 in, I don't have any work, I just have to work that out. I don't have any like solving of an equation to do. If I put a 22 here, oh shit, I got to multiply, and I got work to do. So that's why they give it to us in two different forms. So now that I know C is 22, I can just throw it in there and work that out. Is that cool?
I got a weird answer though.
Totally.
Yeah.
5 doesn't go into 22 evenly, but it's pretty close.
Well, I got a fraction as part of the answer, like 198 over 5.
Well, yeah, but I mean, you get a nice decimal here too. So here it's okay to use decimals because, I mean, if I ask you how hot is it going to be tomorrow and you say, well, it's going to be 110 divided by 3 degrees. No. Tell me point whatever degrees, right? So, yeah, you just divide that in.
Are you playing with like?
Oh, yeah, but I'd rather divide first to make things smaller, right? Does that make, I mean, so what do I have to do to 22? I have to multiply by 9, and I have to divide it by 5. Nobody said I had to do one or the other first. Just both of those things have to happen. So it's 4.4, right? So that goes in there, 4.4. And then 4.4 times 9. Yeah, and then just add 32. Yep, because that's what it tells me to do.
So you just do 198 divided by 5.
Yeah, you could do that also.
So how'd you reduce it first?
Because I can. So how do I do this? Would you multiply after everything we talked about with fractions, or what would you do that's better? When you reduce first?
7 plus.
That's all I'm saying here. I'm saying reduce first, so that you have smaller numbers. That doesn't matter which way you do it. No, it's going to come out to be the same number in the end. That's part of the nice thing about it. It doesn't matter which one of these you do first. You just have to do both of them eventually. So I would hope to God that if the problem was 9/5 times 40, that none of you would do 360. That's silly. 5 goes into 40. 8 times 9. Yeah, see? Yeah. Much better.
That's a 9?
Here, yeah.
Okay.
Yeah. Yeah. So never take it, You've got those written in the book, thank God. And they have the aid of a computer writing it for them. So you should always get your equations from the book. Yeah. My 9s look like 8s, I know.
Which problem was that?
294 on page 661, section 75. Okay. Anything else from homework stuff? I like this. Good questions. Yes?
Evaluate expressions using the commutative and associative properties. So,
Where are we at?
number, let's say 46 or 49 on 7.2, which is 618. Just because our questions are 45, 48.
Oh, I'm with you. Okay, now watch. Here's the idea. If I ask you, all right, can anyone do that really quickly?
Yeah.
Yes. I'm going to use commutativity. It doesn't mean I have to rewrite the damn thing. All commutativity says is I can move individual things around. So what happens with 8 and minus 8? Gone. 5 and minus 5. 6 and minus 6. So the answer is 2. I mean, don't start going 8 plus 5 is 13 plus 6 is that. The whole point of all those problems right there is look for things that will cancel. Right? So if I had 5, 6 times 11 over 49 times 6/5. I feel so bad for the person doing 55 over 294. Holy shit.
5 for the 5, 6.
5, 5, 6, 6. There's the answer. I mean, that's the whole. So what am I really, really doing? I'm really taking 5, 6, and I'm moving the 6/5 over because I know that commutativity is true for multiplication. Do I actually have to rewrite the whole problem? No, you can do what I just did. But why is that allowed to jump over that? Because commutativity. It doesn't matter what order you multiply things in. Yeah. So it's same idea as if I had 8 plus 2 plus 4 plus 6 plus 5 plus 5. Well, there's 10, 10, and 10. That's 30. I mean, I'm not going to go 8 plus 2 plus 4 plus 6 plus 5. No. 10, 10, 10. 30. Done. Next. All right? Okay, maybe. Or how do you do your checkbooks? I'm sure some of you guys do all the positives together, and then you do all the negatives, and then you subtract them. So what have you done? You've used the commutative property. You don't even have to know the word. Just do the word. It's just how our number system works. It doesn't matter if you know the word. Yes?
Can I see the plan of this?
Sure.
Thank you so much.
Quick question. If you took a look at number 48 there, would you, I mean, I know that's in parentheses there, and that's supposed to be 11, and I could just cancel out the 5, 6, and the 6, 5, but
Yes.
can I just do that right off the bat and say, well, screw it, it's going to be the same anyway?
Yes, please do.
Okay.
Yeah.
Because I wouldn't times it and times it.
Yeah, cancel. Yes. Anything else from homework stuff? Okay, yes.
288, this is 0, so would the answer come out?
Well, no. 0 degrees Fahrenheit, so they give you 0 degrees Fahrenheit. Which equation would you use to turn that to Celsius? The second one, because I can plug a 0 there. See, it's not going to come out 0. Plug a 0 in there. 5 9s times negative 32 is going to be some freaky little number.
I was just like, I was kind of asking if you did that. Wasn't that just a little bit of that problem?
Oh, well, here it is. There, it's done a little bit.
Yeah, I'm sure from being like 9 over 5.
No. We talked about where these came from last time. So I'm not going to rewrite them. We talked about boiling point and freezing point and trying to make it make sense as to why that's 9/5. But now this is an equation that translates from Celsius to Fahrenheit. And this one goes the other way. That's all. Yeah. So last time we talked about, hopefully made a little bit of sense, we haven't done graphing yet. So I don't know if any of you guys know y equals mx plus b. All right, so that's like the slope, and that's the y-intercept. So actually you could construct it like that, but we haven't officially talked about graphing yet. So I couldn't do it that way. So I tried to make it make sense as far as how much the temperatures change. That's really what the slope means. And we saw that it was 9/5 of a degree every time. So that's where that 9/5 comes from. But if you actually constructed the equation of the line using points from the boiling points and the freezing points as points, then you could construct the equation, y equals mx plus b. Construct it. And these numbers would fall into place. Not understanding anything I said, you still know these are two equations that translate from Celsius to Fahrenheit and vice versa. Right? So they are the ways to translate between those two systems. Anybody know a third system of temperature measurement? Chemistry, you use it. Something called Kelvin. Yeah, whenever you hear about absolute zero, that doesn't mean 0 Fahrenheit, 0 Celsius, because you can get colder. Absolute zero means you cannot get colder. That's 0 degrees Kelvin. Kelvin measures actual energy in the system. So 0 means we're all dead, basically. Right. Okay, so enough of Kelvin. Don't worry about Kelvin. We won't talk about Kelvin anymore. Anything else from homework stuff? All right, you guys look appropriately oppressed. Let's see. So we do have to finish out section 7.5. We have not done the other side of that handout from the other day. Anybody still need that handout now that a few more people stumbled in? The one with the metric system on one side and unit conversion on the other side. Anybody still need that handout? Very, very quick review of metric. And some of these you guys know, even if you weren't here the other day. Kilometers. You've all heard kilometers. Meters, of course, is there in the middle. Centimeters, millimeters, right? And it's all in that handout about the prefixes. But then you have hectometers, decameters, decimeters. Decimeters is awesome because it's kind of like the decimal. Meters would be whole meters. This would be decimal meters. Like this is 1/10 of a meter. So that's where the decimals start. Yes? Yes, that's why I gave you that saying. What's the saying?
King Henry died Monday, 15.
So King Henry died Monday for meters. You got grams, giggling, unit, laughing for liters. This is a beautiful.
Like, do we have to memorize like how many meters are in?
Well, that's the other beautiful thing. If I have 1 kilometer, how many meters is that? You don't have to memorize it. I go, how many steps in which direction? 1, 2, 3. So then you move the decimal. 1, 2, 3. So I'm going to have 1, 2, 3 zeros. Kilo means 1,000. So I wouldn't memorize those. Hell no. Some of you guys might already know that kilo means 1,000. If you watch enough, you know, kilo of cocaine, whatever. Right? So meters, of course, are the length measurements. We could also have mass or weight measurements for grams. Liters, you actually get 2 liter of Coke, right? So we actually do use a little tiny bit of metric in our everyday life. And what I just did works, period. That's why it's important to remember King Henry dying Monday, doing all this kind of stuff. Because if I ask you, okay, well, 0.078 hectometers is how many decimeters? Well, how many steps do I take in which direction?
3 to the right.
Decimeters, not deca.
3 to the right.
Deci. 1, 2, 3. So then I move the decimal. 1, 2, 3, 78. So if only America used it and you were brought up in this, you would know how to do these things and you wouldn't have to remember how many tablespoons are in a freaking cup. No idea. Maybe. You guys understand the power of this? You understand this is so freaking beautiful? So if I had 143.72 centimeters, how many decameters is that? 3 seems to be my favorite. Yeah, I move it how many times? 3. Yeah, 1, 2, 3. That way. 1, 2, 3. So it'll be 0.14372 decameters. That's awesome. So if you remember how to write the main units of measurement for metric, that's exactly, it tells you how to change. We don't have to remember 3 feet in a yard, and so many yards in a mile, and 740. You don't have to remember all that crap. It's just moving the decimal around. It's a measurement system based on 10, like our number system is. Anyway, so I don't care. Hopefully, nobody thankfully has done this. I had one person do this to me before saying, we don't use metric in America. Why teach that? Well, because we live on the face of the earth, and that's why you want to pass a class maybe, so just shut up and leave my house. Pretty much. All right, so that's metric. That was really quick, but you got the video to watch, and you got I was explaining some stuff on this handout. I desperately need to get to the back of this. So here's the idea of the back of this thing. And let's write down some stuff that we know. How many inches in a foot? How many feet in a yard?
3.
How many, let's see if you guys remember. How many feet in a mile? I like it. All right, let's try to work with this real quick. So if I told you that I have, let's try something not too crazy, Jeff. All right, Jeff. Let's try this. 8,700 yards is how many feet? Let's just start there. All right, now, I know, now some of you guys are not going to have to do what I'm about to do. But the point I want to make is, you're either multiplying to convert, or you're dividing to convert. Did you get that last time? The metric? No? Okay. Do you guys understand what I'm saying? So, like, 12 inches is a foot, right? So 24 inches would be, you divide it, 24 divided by 12. Because every group of 12 makes 1, so there's 2 groups of 12 that makes 2. So you're either dividing or multiplying. That's really all you're ever doing. So some of us are able to tell when to do which one. So what I'm about to do is for those of us who don't remember when to do which one, and also if I have multiple steps to take. You see how far apart these are? It's one step apart. But what if I went from inches to miles? How many steps apart are they? Now it's a couple steps apart. Okay. Now stay with me. So some of you guys do not have to do what I'm about to do. I understand that. So here's how this works. What I want to do, what I have to realize with unit conversion is that I'm changing the units, which means I'm multiplying or divided by a number. But I want to multiply by 1. What do I mean by that? Well, here's what I mean. What units do I not want there anymore? Where am I at to begin with? I'm in yards, and I want to be in feet. So I want to get yards. I want to get them out. I want them to die. So how do I kill yards? Would I put them up here or down there? Yeah, do you guys see how that would cancel then?
Yeah.
I like that. So I want to end up in feet, so I'm going to put feet up here. So I made this ratio here, right? How did I know where to put yards? I just put it so it would kill the yards that were there that I don't want. So if that was feet, I would have put feet down here. Ooh. Now how many feet are in a yard?
3.
So this ratio, 3 feet to 1 yard, is 1. Because 3 feet is 1 yard. What's something divided by itself? 1. So if I take this number and I multiply by this, I haven't changed the amount. I've just changed the units I'm using. Does that make sense? I'm multiplying by 1, which means it can't change really. I'm just changing the units I'm using. So whatever 8,700 yards is, the answer is going to be a different number, but it's going to be the same distance, just measured with a different measurement. So I could say this is about 2 feet. I could say this is about 24 inches. It's 2 different numbers, right? Same stupid distance. Are you with me? So I'm changing the number, but I'm not changing what it's the amount that it's measuring, of course. It's still the same amount. So what do I get? So now what do I do? What does this tell me to do with these 2 numbers? Well, it's up top, so I'm going to multiply. If that was down here, I would, okay, that's it. That's all there is to unit conversion. That's it. So what is 8,700 times 3?
26,100.
Beautiful. 26,100 feet. All right, let's do another. That one was nice. Let's try another one. So what if I had, let's see, what you got, Jeff? What if I had 0.078 miles, and I want to know how many inches that is? All right. So one step that people skip with these problems is the path you're going to take. What path am I? Where am I at to start with? Miles. Can I go straight from miles to inches? No, because I don't have a conversion between miles and inches. I can go from miles to feet, and then, of course, from feet to inches, right? So the path I want to take is miles to feet to inches. All right, you're the side. You want to go away. All right, so now that I know my path that I want to take, the beautiful thing is the very first step, there's really no math involved. Not really. Where am I going to put miles? Because I don't want it anymore. I want it out of the way. On the bottom. It's crazy. And now, so I'm going to put feet on top because that's my first step. Bam, bam. And where do I don't want feet. So where am I going to put feet?
On the bottom.
And I want to end up in inches. So this is what's called unit analysis. Just making sure the units get out of the way and the right units end up in the right place. The miles cancel, the feet cancel, so whatever I get is going to end up in inches. And now you set up ratios that are true, that are just one, that are representations of one. So I'm not changing this. I'm not really changing the amount this is. I'm changing the units, which of course is going to change the number, but it's still the same amount, whatever that is. So what goes here? How many feet in a mile? 5,280 feet in a mile. And how many inches in a foot? 12. So still, what am I doing with all these numbers? Nobody is on the bottom, so I'm just multiplying all these. If anybody's on the bottom, I'm going to divide by that number. So then whatever that multiplies out to be.
Why would a number end up on the bottom?
It's like 4,600 something, huh?
Why?
We'll do a problem with that. Yeah. Notice how, do you guys see how the problems I've done so far? Didn't I start with the bigger unit and convert it to the smaller? Bigger to smaller. That's when you're going to multiply, because every mile has a bunch of feet in it, and every foot has a bunch of inches in it, right? So I got to multiply and multiply. If I'm going from smaller units to bigger, then I'm going to divide. Do you have to remember that? No. If you do this, the numbers are just going to fall in the right place. So what do you guys get?
4,914.
Okay, I was pretty close. Wait, whatever? Or no, does it come out to be that exactly? Neato. Yeah. All right. Let's see. Let me throw one more thing in the mix here to show you how crappy our system of measurement is. I don't know if you guys realize, 1 inch is 2.54 centimeters. Just to give you something else to work with here. So let's say I have, what you got, Jeff? Let's say I have 800 centimeters. And I want to know how many yards that is. So you guys try to set that up. See what happens. And again, this is, I'm never going to see what you're about to do. So there's literally no pressure on you. Just do something. You know, try to make sure it actually makes sense what you're doing. So let me make sure, what path are you guys going to take? From centimeters I can go to inches. From inches I can go to
Yards.
Or wait, no, inches. You can go to
feet. And from feet I can go to yards. All right. So of course the one I give you to do on your own has more steps. Let me write that down. So where do you guys start off? Centimeters. So where are you going to go? From centimeters I can go to inches. Oh, you need that one?
No, I was just going for the thing that you passed out.
Oh, here? This guy?
Yeah.
All right. From centimeters, I can go to inches. From inches, I can go to feet. And from feet, I can go to yards.
It's gonna be a long line. The last.
Now, the very first step you take has no numbers involved. There's no numbers involved in your very first step. What your very first step is to make the units do what you want them to do. We're the humans. We created the units. They do what we want. Do we want centimeters?
No.
No. So get rid of them. How do I get rid of them?
Put them on the bottom.
Put them on the bottom. From centimeters, I go to
Inches.
See, that's why that's useful. All right, now we're in inches. Do I want inches?
No.
No. How do we get rid of them?
Put them on the bottom.
All right, and then from inches I go to feet. Do I want feet?
No.
No. And then from feet I go to yards. Now you can fill in the numbers that go from one to the other. So what do I know about inches and centimeters? There are...
1 inch and
Yeah, where do I put the 1?
on top.
Because that's where the inches are. I always have somebody ask me, how do you know where to put that number? I put it next to the unit that it talks about, right? 1 inch, 2.54 centimeters, 2.54 centimeters.
Wait, where'd you get the 1 inch?
Right here.
There.
So look at the units. Is there anybody that has a question about how I did those units? Why did I put the centimeters here? Somebody have a question about that? It's okay if you do. Yes?
I thought that 2.54 would be on top.
But what's the conversion? What's the known conversion say? 2.54 centimeters is in 1 inch.
Okay.
2.54 centimeters. Do you guys see that? There's no ambiguity. There's no guessing. Why did I put the centimeters there? So that we kill those. Why did I put the 2.54 there? Because that's where the centimeters are. Right? So it's kind of like the first step, you make the units work, and the second step is you put the numbers where they're supposed to go. So here, what about feet and inches? What do I know about feet and inches? There's blah, blah, and blah, blah.
There's 12 inches and 1
12 inches
and 1 foot.
and 1 foot. Why did I put the 12 down? Because that's where the inches are. Why are the inches down there? Because I had to put them down there so they die. And now, yards and feet.
3 yards and 1
3
foot.
yards.
3
3 feet and
feet,
1 yard.
1 yard. So now this one, am I doing any multiplying at all?
No.
No, everything is on the bottom, so it's going to be 800 divided by 2.54, divided by 12, divided by 3. Everything's divided. Every time there's a number on the bottom, you divide it. Yes?
So you go 800 divided by 2.54?
Yes.
Get an answer and divide that by 12?
Yes, or you can actually, if you have a scientific calculator, just put the whole damn thing in there at once. Right? So you don't have to like write a billion decimal places out if it gets to be like that. So you can, in your calculator, type 800 divided by 2.54 divided by 12 divided by 3.
8.748.
Oh, yeah.
What did you guys get? Anybody else got the same thing?
8.7489.
8.74?
8.74890639.
Okay. Blah, blah, blah. And that would hopefully tell you how far to round, right? I would say round to the 100th place or the 1000th place. So yeah, you still have to know those. It never goes away. Maybe I should do it. Yeah, I get that. 8.7489. 0.063, blah, blah, blah. So that's the right number up there. The mistake people make is they do 800 divided by 2.54 times 12. No, 12 is not on top. You divide it by this, divided by that, divided by that. So any number on the bottom, you divide by the number. Any number on the top, you multiply by the number. That's how to keep it straight. How do we feel so far? Let's do another example, obviously. We're just getting used to this, by the way. I love how you guys are like, the minute I start talking, I don't understand it. Well, there's your, let's try to let it sink in a little bit. Let's do something a little different here. Let's do... let's see. Say 2 cups. It's 1 pint. 2 pints. It's 1 quart. 4 quarts. 1 gallon. And also 1 quart.
So there's no, you're not distributing.
Yeah. So this is all in that handout I gave you. This little table. I would give you this table on a test or a quiz. See it? Yeah, all these are going to be on there. I would hope to God you know 3 feet in the yard, stuff like that. If you don't think you should know that, then holy shit, you should. But, I'll put it down. So it doesn't even really... I'm going to do a few more examples with these. And then I'm going to give you complete nonsense. And you're like, that's all you ever do, Jeff. But you'll see. I'll give you some like alien conversion units. And the process doesn't give a shit. That's what I want you to understand. So here's known units. Where do these come from? Are these from... This is just from, we made these up, right? In fact, this is not what they use in any other country, right? They use liters and stuff, right? But this is what we made up. This is how we do things, because we, got to be different. So what have I said? If I have, what you got, Jeff? 0.14 gallons. How many pints is that? Let's set this up together. 0.14 gallons. So the first step, the way I do it anyway, does not involve any numbers. You just have to figure out how to set the ratio up to make the units come out right. So where am I going to put gallons, of course? In fact, what's my path going to be? Gallons to quarts to pints. I like it. So where would I put gallons so it will cancel? So if I put them up here, when I get gallons squared, which is really exceptionally freaky, don't do that. We want the gallons to die because I want to replace it for a minute with quarts. But I don't want quarts. At the end, where would I put quarts? On the bottom. Because I want to have